Hello, my name is Hossein Negahban. I am a professor of physiotherapy at Mashhad University of Medical Sciences, and in this video I would like to talk about canonical correlation analysis, or CCA. At first, it is necessary to note that when you have one independent or predictor variable and one dependent or criterion variable, the best correlation method is Pearson or Spearman. It means bivariate correlation analysis. In the case when we have multiple independent variables and one dependent variable, the best correlation method is regression analysis. However, if we have multiple independent or predictor variables and multiple dependent or criterion variables, the canonical correlation analysis, or CCA, is the best choice. Because canonical correlation analysis evaluates the correlation between a synthetic criterion and synthetic predictor variable, the CCA can be conceptualized as a simple bivariate correlation between the two synthetic variables. Actually, the CCA is a multivariate technique that has several advantages over other relationship analysis, such as regression analysis. More specifically, due to simultaneous comparisons between multiple predictor and multiple criterion variables, the CCA avoids the inflation of type 1 error rate that occurred during multiple univariate analysis between variables. For conducting CCA by the SPSS, you should have 4 SPSS syntaxes in your working directory. 3 fixed syntaxes that do not change for any data, including canonical correlation scoring syntax, and commonality coefficients, and 1 variable syntax that you should insert some changes within the commands. The name of this syntax for my own data is syntax for multiple sclerosis, or MS. You can have access to these syntaxes by reading the following papers. First, Revisiting Interpretation of Canonical Correlation Analysis, that has been written by Niemann, Hansen, and Gates. And second, Conducting and Interpreting Canonical Correlation Analysis in Personality Research, that has been written by Sherry and Hansen. Okay, now we should open the variable syntax. It means syntax for multiple sclerosis. First of all, you should change the path of your working directory. And for this purpose, go back to your working directory, copy the path from here, and paste in this section. Then you should change the name of your data set in different sections of the commands, including get file name. The MS should be changed to your own data file. Also, save out file. Again, this name should be changed. And also DB for predictor variable should be changed, and DB for criterion variable, the MS file name should be changed to your own data. And finally, within the variable syntax, you should change the name of predictor and criterion variables based on your own data. Please note that our research question is to find relationship between some disability outcome indexes such as pain, fatigue, spasticity, balance, and gait, and also some quality of life outcomes, including quality of life A, B, C and D in patients with multiple sclerosis. You should change these predictor and criterion variables based on your own data, and these changes should be inserted also in the following section: IND for predictor variables and also IND for criterion variables. Between variables, you should insert a space to run the program. Okay, after you insert these changes, it is the time to execute the program for extracting both traditional and contemporary parameters. First, you should select this section started from the star symbol until the end of this section and click Run Execution. By clicking this command, you will prepare the program for execution. Second, you should select CANCORR until the end of next line and click Run. And by this command, you can extract some traditional parameters, including standardized coefficient, structure coefficient, that I will talk about that in the later section. Third, you should highlight this line and again press Run. And by running this command, the program will create one data file entitled Multiple Sclerosis A, that further canonical analysis is based on the parameters extracted from this new data file. And at the end, go back to the variable syntax. You should extract some contemporary analysis by selecting the command starting from the exclamation symbol from here until the end of criterion variables and click Run. By clicking this command, you can see that the SPS is opening and closing some windows until the computation finished. Therefore, after computation, you can see that the SPSS in your working directory create 3 output files for criterion variables, including criterion commonality matrix, criterion CC by variable, criterion APS, and 3 output files for predictor variables, including predictor commonality matrix, predictor CC by variable, and predictor APS. The contemporary parameters are including unique and common effects that I will discuss about that in the next section. Okay, now we go back to the first output. In this output, you can see some correlation coefficients within criterion and also within predictor variables, and also you can see some correlation coefficient between predictor and criterion variables, that all of them are not of interest for our purpose. Firstly, in this output, we should answer this question: does a significant relationship between two variable sets, it means predictor and criterion variables, exist? And to answer this question, it is necessary to evaluate full canonical model for both statistical significance and practical significance. For statistical significance, we should look at the p-value of the Wilks lambda test, and for practical significance, we should look at the value of Wilks lambda. A p-value equal or less than 0.05 can be considered as statistically significant. The Wilks lambda represents the variance not explained by the model. Therefore, the amount of variance shared between two variable sets can be expressed by 1 minus lambda value, it means effect size. In other words, these effect size values represent the extent to which the full canonical model captures the relationship between two criterion and predictor variable sets. According to some literature, the amount of this value, it means 1 minus lambda value, should be minimally equal or greater than 20%, because only the first canonical function has the effect size greater than 20%. 20% in our example, we should extract the parameters specific to the first function. Till now, we determined that we have some relationship. So it is the time to answer the second question in our interpretation strategy, that is, what variables are contributing to this relationship between two criterion and predictor variable sets. And to answer this question, we should extract some traditional and contemporary parameters. The most commonly used parameters are including standardized function coefficient, structure coefficient, and squared structure coefficient. For extracting the standardized function coefficient, we should follow the values related to a standardized canonical coefficient for set 1, it means predictor variables, and a standardized canonical coefficient for set 2, it means criterion values, both of them just for function 1. Also, you can pick up the information regarding the structure coefficient from canonical loading for set 1, it means predictor variable, and canonical loading for set 2, it means criterion variables. It is necessary to note that information regarding the raw canonical coefficient for set 1 and set 2, and also cross-loading for set 1 and set 2 are not of interest for our purpose. Now we can have a look to our results. In this table, you can see that 3 columns related to traditional parameters extracting from canonical correlation analysis, including standardized function coefficient, structure coefficient, and squared structure coefficient, and 3 columns for canonical commonality analysis, means contemporary parameters including unique effect, common effect, and total effect. Among the criterion variables, the last variable has the largest magnitude of both standardized and structure coefficients. It means the relative magnitude of standardized coefficient for this variable is consistent with its structure coefficient. However, among the predictor variable, the fatigue variable has the largest standardized coefficient, while the balance variable has the largest structure coefficient. In other words, the relative magnitude of standardized coefficient is not consistent with its structure coefficient, and this inconsistency may be due to the presence of multicollinearity and suppression effects. In this situation, further analysis, it means canonical commonality analysis, is necessary for fully interpreting the results by determining the unique and common effects. For extracting these contemporary parameters, we should open predictor CC by variable and criterion CC by variable. For example, if we open predictor CC by variable, output phi, okay, you can see in this table, balance has the highest unique effect, while fatigue has the highest common effect. To determine which combination of this variable has the highest correlation, it is necessary to evaluate the coefficients provided in the output file entitled predictor commonality matrix. And if you open this file, you can find that which combination of fatigue variable has the highest correlation with other predictor variables. Yes, you can see this file. Thank you for watching this video, and if you have any questions, please contact me via email, and my email is honegahban@yahoo.com. Bye bye.